So all trunking protocols we discussed right yesterday, like what is trunk and how to enable trunk dynamically, DTP dynamic trunking protocol, and VTP VLAN trunking protocol. All trunking protocols are done. Trunk port allows multiple VLAN traffic by adding Ethernet headers to the frame called trunk encapsulation mechanisms are two protocols. 802.1q and ISL. ISL is a Cisco proprietary protocol and 802.1q is open standard. Right? And what is the header size of ISL? ISL header size
34
30 bytes. 802.1q header size
4 bytes.
bytes.
4 bytes. So moreover is the open standard. It's simple header, faster communication. Even in Cisco devices, in Cisco switches by default, 802.1q is enabled actually. Next is DTP. We can configure trunk between the switches dynamically, automatically. One side if we configure trunk, other side automatically trunk will form. Because DTP, there are two modes in DTP, dynamic desirable and dynamic auto. So default, all ports are dynamic auto. It's passively waiting to receive trunk negotiation messages. Dynamic desirable actively initiate negotiation messages. So one end if we configure dynamic desirable, it actively initiate negotiation messages. In other end is automatically is waiting actually, but it's passively waiting to respond for that. So it will be workout. And VTP, VLAN trunking protocol is also Cisco proprietary protocol. It is to maintain VLAN configuration consistency throughout the network. So it works in three modes: server mode, client mode, and transparent mode. If we create a VLANs, if we delete VLANs, if we modify VLANs in server, it will replicate to all client switches. So any modifications done in server, it will be replicated to all client switches actually. So we can create, we can delete, we can modify VLANs in only in server. If when switch is in a client mode, we cannot create, we cannot delete, we cannot modify VLANs. In transparent switch, any specific VLANs, if you require any specific switch, you can make that switch is a transparent and you can create a VLANs. So that VLANs will not replicate it. It all synchronizes with any other switches like a server and client. So synchronization will happen only between the server and client only. To synchronize the VLANs information, switches must configure same domain name and same password. Domain name and passwords are case sensitive. Got it?
Yes.
So yeah, these are the topics yesterday we have covered, and today let's continue with how to forward the traffic from one VLAN to another VLAN. Same example. You can one switch A to different departments. Device 1 connected to port number 1. On port number 2 there is one more device. Say on port number 5, on port number 6. So first two computers are belongs to sales department. The next two devices is belongs to HR department. So here I have one simple question. My question is, for sales department, 192.168.1.0 network IP address we can assign. Like 1.10, 1.20, like 1. Network IP address assigned. And HR department, you assign IP address in 192.168, 2. Network IP address for HR department. Now tell me, HR department, sales department, will they communicate?
Yes, it's coming.
No.
How they can communicate? They are
They
in
cannot-
different networks.
Different
They
networks,
cannot
yeah.
communicate.
They cannot communicate. Then why we need to create a VLANs then? Instead of assigning or creating a VLANs for each department, make them into different networks. Anyhow, they don't communicate now. See, now sales department in VLAN 10, HR department in VLAN 20. Will they communicate? No, because they are in different VLANs. Similarly, I make them into different networks. So what my question is here, instead of creating a VLANs, we just make them into different networks, but still we used to create VLANs. Why?
Some IP addresses.
Of network.
To save the IP addresses, then we have a concept called subnetting. We can do one network and subnet, and you can use one subnet for sales, one subnet for HR. That option is also available. Agree? Right.
Secure.
Main point is not the networks actually. Sales department ports, HR department ports. Rest of remaining all ports by default will be on which VLAN?
VLAN 1.
VLAN 1. Now sales user traffic is generated. It is trying to communicate with sales PC only. So switch will do broadcast
Yeah.
irrespective of the network. So by the way, switches don't understand the network IP address. So what switch will do? Switch will just take MAC table. If the destination device address is available, then unicast. Is not available, broadcast. Broadcast to all VLAN ports. So broadcast is the main concept for VLANs. So to minimize the broadcast and to provide secure access, we must create a VLAN. So I make them into VLAN 10 for sales department, VLAN 20 HR department. Now broadcast happen to only 1-2 ports. Agree? Now broadcast will not come to VLAN 20. But our requirement is what now today? How sales and HR can communicate. The target actually. So how to enable communication between two different VLANs? Before understanding two different VLANs communication, first anyone can tell me how to enable communication between different networks?
Router with routing protocols.
Yeah. So to enable communication between two or more different networks or two or more different VLANs, we must require layer 3 device. What is a layer 3 device?
Networking device which is called router.
Yeah, router. Router is layer 3 device. Or we can use L3 switch also. So to enable communication between two or more different VLANs, there are two methods. One is using router, we can enable communication between different VLANs, or using layer 3 switch also can be done actually. Okay. Let us see using router how it can be possible. I'm using a router. From router LAN port, I've connected a switch to port number 3 from fast Ethernet port. For fast Ethernet 0/0, IP address 192.168.1.1 have assigned actually. And link is up. See, whenever you assign IP address to fast Ethernet and link is up, we can get an update in routing table. Agree? Because router always will functioning based upon routing table only. Now tell me routing table update. 192.168.1.0 is directly connected to FE00. Okay, router is available, router connection is connected, in interface IP is assigned, and even interface is up, routing table is up. Now let us check how different VLANs can communicate. VLAN 10 user trying to communicate with VLAN 20. What is source IP address? Source IP is 192.168.1.0. Destination IP address 2.network. Packet generated. We'll come to router. What router will do always? Router always will check routing table, how to reach a destination. The source is available, 1.network is available. What about 2.network? 2.network is available in routing table? No. If destination is not available, then
It drops.
it drops the traffic. If it is dropping the traffic means then how different VLANs can communicate? A destination network must be available in routing table. So can do one thing. I'm connecting one more interface to switch port number 4. This is fast Ethernet 0/1 0/1 192.168.2.1. It is VLAN 20 network. And link is up. Right? I can see routing table update. 192.168.2.0 fast Ethernet 0/1 is connected, directly connected. Source network is available, destination network is available. Now different VLANs communication is possible actually. So all VLAN 10 traffic will come to router via port number 3. I'll go to router. Router will check routing table. Yes, I know how to reach 1.network. I know how to reach 2.network. So packet switch from fast Ethernet 0/0 to 0/1 and trial come to port number 4. Now port number 4 will broadcast to VLAN 20. Communication is enabled. It's clear everyone?
Yes.
Yeah. So this is how we can enable communication between two different VLANs using a router. Okay. In this first case, between how many VLANs we enable communication? VLAN 10 and
Only two
VLAN
VLANs.
20. For two VLANs, for two different VLANs, to enable communication, how many router ports are used?
2.
How many router ports we required?
2
Two
ports.
router ports. How many switch ports are required?
Same number, 2 ports.
Port number 3 and port number 4. 2 switch ports. How many cables are used?
2 cables.
2 cables. So for 2 different VLANs, we must require 2 router ports, 2 switch ports, and 2 cables. Like what if my requirement is for 10 VLANs? Want to enable communication between 10 different VLANs? Then how many router ports are required? How many switch ports are required? How many cables are required? 10 router ports, 10 switch ports. For each port, each network. No? Right?
Yeah.
Yeah. So this is the drawback in the first case. So this is not a best practices. This one type of method option is available. We don't use this first method actually. In first method, we required multiple ports, multiple router ports, multiple switch ports, multiple cables. We have next method, same using a router. Using a router, only one interface, one router port, one switch port, one cable. Using these, we can enable communication between multiple different VLANs. Not only between 2 different VLANs, not different between 10 different VLANs, any number. Multiple VLANs can be communicated using this method actually. But ultimately, each VLAN should be in different network. And every network must be available in a routing table. But here you have only one interface. Then how routing table will update? Agree? Routing table. So point is, one physical interface, which is fast Ethernet port, you connected cable. FE0/0 port number, you connected a cable, right? So under this physical interface, we can create multiple sub interfaces. FE0/0.1. This is one interface. We can assign one IP address for this interface. This is for one VLAN, VLAN 10. Like fast Ethernet 0/0.2. This is another interface. One more sub interface we call sub interface. So this interface we can assign one IP address in VLAN 20 network for VLAN 20. .3, .4, .5, like n number of sub interfaces can be created under one physical interface. Got it? So now you can see routing table update like this. 192.168 1.0 is directly connected to FE 0/0.1. One 192.168 2.0 directly connected to fast Ethernet 0/0.2. Two sub interfaces. So all VLAN 10 traffic can reach router via which port? VLAN 10 traffic or VLAN 20 traffic or VLAN 30 traffic. What are the VLANs in the LAN? That VLAN's traffic can reach router via which port as per this diagram?
Port number 3.
Port number 3. So VLAN 10 traffic can reach router via port number 3. Even VLAN 20 traffic can reach router via port number 3. If port number 3 is a access port, if it is an access port, then access port allows how many VLANs traffic?
Only
One
one
VLAN.
Only one.
Only one VLAN traffic. But what is our requirement here now? VLAN 10 traffic
Multiple.
should allow multiple. Then
Trunk.
the port where router is connected and the switch, that port must be configured as what?
Trunk.
Trunk to allow multiple VLANs traffic. This is very, very, very important point. Don't forget. A port where a router is connected and the switch. That port must be configured trunk to allow multiple VLAN traffic. So forwarding traffic from one VLAN to another VLAN. This method we call inter-VLAN routing. We configure routing between the VLANs actually. Inter-VLAN routing, IVR. Inter-VLAN routing is a process of forwarding traffic from one VLAN to another VLAN using a router. A port where the router is connected in the switch should be configured as trunk to allow multiple VLAN traffic. A physical interface, one physical interface on router is divided into multiple sub-interfaces. Each sub-interface we can assign one IP address and one VLAN. So this process also we can call as router on a stick, ROS, router on stick. Okay. Yeah, symbolically, you can see a router on stick means one interface. This is router on stick actually. Here is only one interface. Right? So which is the best method? First one or second one?
Second one.
Second one.
Like later, VLAN 30 also in order to enable communication, create one more sub interface. Interface fast Ethernet 0/0 dot 3 as an IP address. Dot 4, dot 5, dot 6, dot 7, n number of sub interfaces we can create. Even that VLAN in a switch 2. See here we discussed VLAN 10, VLAN 10 on router on the same switch, right? Even VLAN 30 is in switch 2 or switch 20 or switch 80, wherever VLAN is available, that can communicate via this router actually. But they should be interlinked. All switches are interlinked. Getting my point? Yeah. So two methods. The first case using router, multiple physical interfaces. In second case using router, only one physical interface. Next method, third method is router not required actually. No need of router. When if the switch is layer 3 switch. So layer 3 switch is also router, right? Layer 3 switch itself is a router. Agree? Then how layer 3 switch can enable communication between different networks, different VLANs? The first thing is layer 3 switch by default, it is not a layer 3 switch. I repeat, layer 3 switch by default, it is not a layer 3 functionality. We need to activate layer 3 functionality. Layer 3 functionality means what? We need to activate router functionality. What is the main mechanism of router? How router works based on what?
Or
Based on routing table. Agree? If any device maintain the routing table, that device is a router. Simple I can say. Any device, it can be a router, it can be a firewall, it can be a switch, it can be your PC. The device which maintains the routing table, on the device there are router functionalities available. Got it? Yeah. So, but by default, layer 3 switch is not a router. So when this layer 3 switch can act like a router, we need to enable routing on this switch. So first case, enable routing by using simple command, IP routing command. If we use this command in layer 3 switch, then layer 3 switch is a layer 3 switch actually. Functionality, routing functionality will active. In first case, VLAN 10, VLAN 20 can communicate. Communication is possible. We enable communication for different VLAN. You can see routing table, there are physical interfaces, fast Ethernet 00, fast Ethernet 0/1. In second case also, VLAN 10, VLAN 20 can communicate. Different VLANs can communicate. How? Based on routing table. In routing table, there are virtual sub-interfaces. Sub-interface 1, sub-interface 2. Similarly, in third case also, a routing table is mandate. We enable IP routing, routing is enabled. Then how these networks will come into here? We don't have any interfaces. Yes. In layer 3 switch, we need to create interfaces called SVI, switch virtual interfaces. Nothing but a VLAN interfaces. Your VLAN 10 itself is one interface, virtual interface. Can use this command. Interface VLAN number 10. This is one virtual interface. This we call switch virtual interface. Directly can assign IP address. IP address 192.168.1.1 followed by mask. Similarly, interface VLAN 20 IP address 2.1 followed by mask. So created two virtual interfaces. Then your routing table will update like this. 192.168.1.0 is directly connected to which interface? 192.168.2.0 connected to which interface? One dot network is connected to which interface, guys? VLAN 10 interface. Two dot network, VLAN 20 interface. So these interfaces we call SVI, switch virtual interfaces. Now switch maintain VLAN 10 network, VLAN 20 network, then it can easily communication is possible. Simple. These are all the methods we have to enable communication between different VLANs. Routing between VLANs can be done in three ways using multiple physical links called legacy inter-VLAN routing, using a single physical link and creating sub-interfaces called router on a stick, using multi-layer switch. The three methods we have. So these are commands to configure sub-interfaces, to create sub-interface and routers. Any doubts? Okay. Total how many devices in this picture? In packet tracer file? Total how many devices are there?
Devices means routers or
Total devices, how many devices are there?
6.
6 devices. Out of 6 devices, how many routers, how many switches?
2 routers, 4 switches.
4 routers, 2 switches.
4 router, 2 switches.
Routers, 4 switches.
Yeah. Okay. So total there are 4 routers, 2 switches are there, right? If you consider first switch is name is switch A or switch 1 or switch 2 or switch A, switch B, like that. Oh my god. Stress. Yeah. In switch A, first switch A, how many directly connected devices? What devices are directly connected?
3 routers and 1 switch.
3 routers and another switch.
3 routers and 1 switch. In first router, connected to which port number on the switch? No idea, right?
No, I'm like,
Okay.
we will have to log into the switch and check using the command.
Excellent. Correct. See, point is here, Sumant, if you have access to switch A, you don't have any access to any other devices in your organization. you have available access for switch A and you log into switch A. But how can get to know for this switch how many devices are connected, what type of devices are connected, and each device on which port number it is connected? And what about directly connected devices information? So is all the information within 60 seconds we can get actually. So now this is R1 connected, and R1 IP address, R1 IOS information, R1 model number is which category, and port number, which port number is connected, what type of LAN port it is, all the information within 60 seconds we can get in switch A. Later sometime this router 1 is removed and added a new router, a new information. See, if new router is added, even that new router information also within 60 seconds you can get. So all directly connected device information, this switch A is going to be discovered using one protocol called CDP, Cisco Discovery Protocol. The name itself is telling is that it works in only Cisco devices. It can discover only Cisco devices actually. It is directly connected Cisco devices. The device can be any device. The device can be router, the device can be firewall, it can be switch, it can be access point, like any Cisco devices are discovered. So CDP is running in all Cisco devices. Even CDP is running by default in switch. What switch will do? So for me, there are 3 routers and 1 switch is connected. It is discovering what type of device is connected also. Is it router is connected, or firewall is connected, or switch is connected, is access point is connected. It will discover all the software and hardware information. Even in other end, if you log into router 1, for router 1 which is directly connected, switch A is directly connected. So router 1 can discover, oh, for me, switch A is directly connected. So if you log into if you log into R1, you can get switch A information. If you log into router 2, you'll get switch A information. If you log into switch B, then what device information you can get?
Router and switch.
So R4 and switch A information you can get. Agree?
Yeah.
Yeah. So it is protocol. It is Cisco proprietary protocol. CDP is enabled by default in all Cisco devices. Advertisements are sent through all ports by default for every 60 seconds. That advertisements, that information advertised via using this multicast address. Okay. So what information advertising? Advantage of CDP protocol. Once layer 1 is active, CDP sends information to active neighbors. Information advertised by CDP, IP address. Logical address means IP address if configured. Host name, device name, hardware platform. Means it is 2800 series or 2600 series or 5000 series. At hardware platform you can get to know. IOS information, is it 12.1 or 15.1? That information. Interface type, is it Ethernet port or fast Ethernet or gigabit port? What type of interface it has? An interface number, on which interface is connected, on 00 or 01 or 05, where it is connected exactly. That information. Let us check. Let me log into switch A and I want to know my Cisco neighbors information. Then can use show CDP neighbors. In privileged mode, you just give show CDP neighbors command. Now here showing capability of the device. R means router, S is switch. There are two routers and one switch is connected. And the first router is 2600 and switch is 2960, and which port number it is connected, and local interface port number, and host name. Joompek is host name, switch is host name, HYD is host name. Actually, for switch A, there are three routers, one switch is connected, right? But here showing two routers, one switch. It means CDP might not enable on one switch actually, on any one device. By default is enable. If you don't want to use, you can disable it also. Let us check on third router whether it is enabled or not. Bangalore, yeah, it is not enabled actually. We show run command. It is showing no CDP running. So CDP is not running in this device actually. Let us enable CDP. In config mode, simple, CDP run. CDP is enabled. And what is the command to disable?
Run.
No CDP run.
No CDP run. So now if we check again from switch 1, show CDP neighbors, yes. You can see Bangalore device also is there. Port number 3 is connected. It is router, which is 2600 series. But what about IP address of the devices? What about iOS version of the devices? So you want to see the more information, then you can use command detail. Show CDP neighbor detail. You can see IP address entry 2.1 and iOS version is 12.2. Like all the details information you can get actually, complete information. Show CDP neighbors, show CDP neighbor detail. Clear everyone about CDP protocol? CDP run. Any disadvantage of CDP?
Security?
Like it can discover only Cisco devices in your network, right?
Yeah.
Like what if you have non-Cisco devices in your network?
It will not discover.
So that is drawback actually. But we have one more protocol to discover Cisco and non-Cisco devices. Disadvantage of CDP, CDP can be used only between Cisco devices. Information about only directly connected neighbors can be known. Another protocol is LLDP, Link Layer Discovery Protocol. Both are discovery protocols. CDP discover only Cisco devices. LLDP discover Cisco or non-Cisco both. Is open standard protocol. Only thing is CDP protocol is enabled in all Cisco devices by default, and LLDP is not enabled. We need to enable it actually. That's all. This open standard protocol 802.1 AB. LLDP is a neighbor discovery protocol used by devices for advertising information about themselves to other devices on the network. By default, it is disabled on Cisco devices, but CDP is enabled. LLDP is disabled. We need to enable, we need to manually enable it on the devices actually. Advertisements within 30 seconds we get information. If a CDP within 60 seconds we'll get, but in LLDP very fastly. Within 30 seconds we'll get information actually. The multicast address.
You run both CDP and LLDP at a time, the same time?
Yes, we can enable. Yeah.
Okay.
CDP is already running in your Cisco devices. You just enable LLDP, then both works.
Okay.
Show CDP neighbor. Show CDP neighbor detail. But how to enable
CDP run.
in config mode? Can use CDP run. How to disable?
No CDP run.
No CDP run. Verification commands. LLDP. So by default, LLDP is not enabled. We need to enable it actually. How to enable LLDP run? How to disable? No LLDP run. Verification about LLDP information. Show LLDP neighbors. For detail, show LLDP neighbors detail. Just to replace CDP into LLDP. That's all. Clear? Okay. Any more doubts? Right. Let's see the next scenario. Say switch A and say switch B. In switch A, some devices are connected. Like all my team, my engineering team is connected to one switch A. And related servers, like for this team, related servers, storage or accessing or share anything, they are connected to switch B actually. All servers are connected here. They are running some scripts. All scripts are stored in here from this storage. They are accessing, scripting, everything. So simple question is how these engineers, how these devices and servers can communicate. All are default VLAN 1, no other VLANs. So simply we need to make one uplink from switch A to switch B. From which port to which port? Do you have any rule to specific port or any port to any port?
Any port to any port.
I have connected one link from any port to any port from port number 1 to port number 1. Agree? What is the differences between a router port and switch port? Say router port, if it is a brand new router, what is the status, default status of fast Ethernet port?
Shut down.
It's a shutdown state. We need to give no shutdown until it will not active, right? What about your switch ports? For every switch port, do you need to give command no shutdown on port 1, port 2, port 3? Is it?
I don't
No.
think so.
No. No. You're connected some devices to switch, it will come to green automatically. So switch ports are by default is what? Forwarding state, active state. So just you connected a one uplink from switch A to switch B. Now log into switch A and no shutdown on port number 1, no shutdown port number B. Is it required? No need. You just a cable, connect a cable between two switches. That cable will come automatically forward state. Correct? Yeah. So port number 1 is forwarding state. Even B1 also is forwarding state. And the devices are connected to 3, 4, 5, 6. Is all also forward state. Servers also forward, like all ports in the switch by default in forwarding state. Then one uplink is connected and users, they are started communicating. They are connected to servers. So everything is up and running my network. What after some time if link between switch A and switch B is failed?
Connectivity is lost.
Let's assume that switch A is in the first floor, switch B is in the ground floor. If link failed and to make a one new connection, new cable, how much time it may take approximately? 1 hour, 30 minutes, 2 hours, say 1 hour or 30 minutes. 30 minutes is the downtime. So up to 30 minutes, the users and servers connectivity will be down now. More downtime. You're running a scripts actually. So every time 24/7, users should connect it to servers. If at least a few minutes is down, there is impact in the scripting and running, automation, programming, everything. So here the problem, you have only one link between A to B. If link fail, no communication. So this type of topologies we call single point of failure topologies. To eliminate single point of failure topology, backup links are used actually. Backup links are required. I'm connecting one backup link from port number 24 to port number 24. So after connecting port number 24, what is the default status of port number 24? Forwarding. Is also forwarding. So once you connected multiple links or two links between the switches, we call this is redundancy topology. You have only one link, we call single point of failure topology. You have a multiple links, redundancy topology. What is the good thing in redundancy topology? What is the advantage of redundancy topology? Even if first link is down, yeah,
one will work.
without any downtime, automatically users can communicate, users can connect the servers via another link. No downtime. High availability, right? So this type of topologies, we call it is what? Redundancy topology. So which type of topologies do you recommend to use for corporate networks? Single point of failure or redundancy topology?
Redundancy.
Redundancy must be there actually. Okay, so you connected two links between the switches and it provides what? Redundancy. Agree? But there is some new problems will come in the picture when you connect a multiple links between the switches. Good thing is redundancy, backup is available, but so you'll get some new problems actually. You know what is the problem? Problems are switch A maintain MAC table. Even switch B maintain MAC table. By default, MAC table is what? Empty. Now first user is sharing some documents to second user. First user is source, second user is destination. What if destination device MAC address is not available in MAC table? What type of communication starts in the switch?
Broadcasting.
Now broadcast will come to port number 3, port number 4, port number 5, port number 8, port number 24. Agree? So that broadcast packet, port number 24, what is the status of port number 24?
Forwarding to another switch.
Forwarding the same broadcast file forwarding to B24. What is the B24 state, port number 24 state? Forwarding. So broadcast to all 24 ports again actually. Now one broadcast packet come to B1. What is the B1 state?
Forwarding. It will go
So
again.
forward back to A1. And what is the A1 state?
So loop.
Forwarding. Continuously one packet. Any one packet is enough to make your a complete network is going to be down actually. Looping. So all ports A24, B24 ports are very busy with continuously forwarding. Loops are forming actually. So one broadcast packet is enough. No, even not require the multiple broadcast packets. Only one broadcast packet is enough. It making is going completely network will down. If continuously forwarding means CPU utilization will reach the 100%. There is more burden on the processor. So sometimes there is chances of hardware failure also actually. If continuously broadcasting for a longer time, CPU will be 100% utilized. Heat will produce. Hardware failures. It seems complete network will be down actually. Getting my point? When we have a multiple links. If it's a single link, no loop. Drawback is no backup, that's all. But here, if you have a connect a multiple two links, then good thing is redundancy, but problem is what? It is going to be down complete network. Loops are forming. Now target is how to stop loops. How to stop loops. Any solutions from your end?
By giving some kind of command to walk only one link. If that fails, to walk the other link.
Good. Okay. Yes. So that can be possible with the help of one protocol called STP, spanning tree protocol. So how its spanning tree protocol works is, so spanning tree protocol is going to making one port is block. It's going to do block the port actually. It's not shutdowning, it's just blocking. Let's say A24 is blocked by spanning tree protocol. BLK means block. It's not completely down, it's not completely active. It is disabled actually. So it is not a forwarding state now. If it is not forwarding, do you have loops here? There is a continuation broadcast? No. But how users can communicate, users and servers, how they are connected, how they exchange the data. Via first link they can communicate actually. Whenever first link got failed, then a protocol, that algorithm, STP protocol will do what? Oh, the first link is down. Then block port automatically within a seconds. Block port will come to forwarding state. Then users can connect the servers via this link action. The downtime will be within a seconds. Again, your link is up. Then loop will form now. So it will not create a loop. Whenever link is up, then the port number 24 will come to block state to stop the loops. This means spanning tree protocol is providing redundancy. So spanning tree protocol used to avoid the loops. And no loops actually. The same time is providing redundancy. There are two links. Two links is there in your network. One link is failed, another link will come up without loops. How? A simple logic STP will do what? Blocking a port. It block the port. When the primary, when one link is down, that block port will come to forward state automatically within a seconds. It's clear, guys? About STP protocol?
Yes, clear.
Then tell me, what is STP? How it works? What is the advantages? What is the use of the STP protocol?
To avoid loops in the network when multiple links are connected.
Right. It avoid the loops. Okay.
It is used for redundancy.
It provide redundancy. Good. How it stopping loops? That's the main question actually. How it stopping loops?
Block the port.
Blocking a port.
By blocking a port. Right. So spanning tree protocol is used to avoid layer 2 switching loops in redundancy topology by blocking a port. Clear? Yeah. To eliminate single point of failure, backuplings are used. This type of network is called redundance topology. See, users and server are connected with one single link. Data is going via one link. What if link fail? No communication. So backup link are used. What are the problems in redundancy topology? So problems on redundancy topology is multiple frame copies, multiple times frames. MAC table, MAC address table instability. You can see MAC table in switch A, in switch B, in switch A, switch B. Broadcast stroms, continuously broadcast. These all the problems collectively we called layer 2 switching loops. Okay. Yeah. Any more doubts about STP protocol? You can see spanning tree protocol is used in switcher network to avoid switching loops. It uses spanning tree algorithm. STP blocks the redundancy path, which is causing a loop. It's open standard protocol. We can configure STP in all devices, Cisco and non-Cisco devices also. So, any more doubts on STP protocol? Yes, please. Have any doubts on STP protocol?
Yeah, what's the command for it? For the STP?
Thing is, by default, STP is enabled in Cisco switches. I'll show you soon practical. See, A, B, C, three switches. I'm making is redundancy topology. A to C, A to B, B to C. Yeah. Actually, if all ports will come a green, then all ports will be forwarded. If all ports are forwarded, then continuously loop will form. But STP is running in all three switches. So what STP will do? STP is going to block any one port actually. You can see all ports will come to green except any one port. That port will remain amber color, like orange color. That is block port actually. See now. Green, green, green. Says this is block port. So this link, traffic will not forward via this link. Out of remaining two links, any one link is down, then automatically this block port will come to forward state. May remove this link. So that link is down. Then this block port will come forwarding state automatically. Okay. So now it is green. Once you are back again, your link is up. Same port will come to block port.
Excuse me, sir. The link is automatically green, showing green or orange or
Means what? No, I didn't understand.
actually before you draw the picture, uh, all ports are orange, right?
Yes.
Then it
Automatically
comes.
come to green. Yeah.
Oh, okay, okay.
You don't have to do anything. It will come automatically green. Only it may take few seconds actually because STP elections is running. And there is some mechanism how it is going to elect the block port based upon election process that we need to continue our session tomorrow actually. So just I introduced STP protocol. Introduction part is done, like why, how it works, and what is the advantage of STP protocol and all. And STP functionality, how STP works exactly, and what we need to manipulate, that will continue tomorrow. But please remember, by default, STP is enabled in all Cisco switches. Any doubts?
Excuse me, sir.
Yeah, please.
Now practically is only CDP and LDP, sir. That's it, right?
Practical?
That's practice is CDP and LDP only. Practice session.
No, for practice session, inter-VLAN routing, different VLANs concept. This is the main practical today actually. So take a switch and create VLAN 10 few pieces, VLAN 20 few pieces, make them into different network, and take one router, connect it to switch, and create sub interfaces. So finally, VLAN 10, VLAN 20 should communicate. This commands you can use to create sub interfaces. Okay.
So router on a stick and inter-VLAN routing isn't used so much, right?
Router on stick, inter-VLAN routing.
Isn't used so much in networking scenario, real-time networking scenario.
Yeah.
I mean,
Both are same, right? Both are same. Inter-VLAN routing is the thing, but both are same. Router on stick.
So what's more important over here, like multi-layer switch or these?
Router on stick.
Router
Router on
on
stick
stick
and
is-
multi-layer stick. These both are used. In the first method, legacy inter-VLAN routing using multiple physical interfaces, we don't use that actually. Mostly two methods we use. Single interface creating sub-interfaces, which we call router on stick, and multi-layer switch. These both methods we use real network. Yeah. So that is your practical today, inter-VLAN routing concept. And tomorrow we'll continue with same STP protocol only. For reference purpose, you can use this diagram. Thank you. Have a good day. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you.